right, everyone, welcome back. We just finished the last break of the day, so we're into the home stretch here. We're going to start with this mini track on lessons from public cloud. As you may have picked up, I think, through some of the presentations, maybe starting with Kaon yesterday and through many other just kind of anecdotal evidences, there are a lot of areas of IT that are further ahead on automation and systemization of infrastructure than networking. And so today we've got a few folks together. Jeff Loughridge, Mark Ciecior, and William Collins are going to join me for this little track to talk about some of the things we can learn from public cloud. We're going to do this track as a series of lightning talks with a Q&A at the end. So I will ask William to, I guess you can present up here or there, wherever you want, but you go first. I'll give you the clicker. And we'll dive in. So please note down your questions, and we'll have a series at the end.
All right, let's go. So I guess first of all, hats off to Chris and Scott. This has been like one of the, I think my favorite event that I've ever been to. It's been a blast. Yeah, give them a hand. It's so much planning, so much effort. It's, yeah, a major undertaking. So yeah, my name's William. I work for a company called Alkira. My history, so I've been with Alkira for 2 years. My history is network engineering, network architecture. On the enterprise side though, so I've tried to do this automation thing many times over the years, and yeah, mileage varied. So first thing I want to look at is, you can't even discuss automation and networking without saying something about culture. It's the core. So we'll talk about culture a little bit. And then I want to take a look at, network management historically and like really fundamentally how it differs from cloud. Cloud is very different. So what are the actual differences at a mechanical level? And then I want to look at one API to rule them all. There's going to be some dark Lord of the Rings undertones in this slide deck. So I don't know if you know who Phil Gervasi is. He's throwing memes out everywhere like whoosh. And, so I've taken a cue from him and I have some memes in here. I'm going to see how it goes. So I don't know if you remember from the first Lord of the Rings movie. I remember sitting in the theater, and I remember when Gandalf the Grey walked out through the data center and his hands were like gliding along the fibers, and everybody in the movie theater was just clapping and cheering. Gandalf the Grey, great. And he said, automation applied to an inefficient operation will magnify the inefficiency. And that's about where every large enterprise is, because they've been around for a long time. There's a lot of people, a lot of process, a lot of things that have to be ironed out. There's no easy button for this anywhere. So understanding those things and knowing to focus on those things and getting an idea of where you're at and like where you need to go, very critical. Culture, 100%. I personally think that's where the big problem of adoption comes from. There's a lot of cultural challenges. So let's look at some network management historically. So being that this is a big room full of a whole bunch of network engineers, I think you all know what complex means. But if you look in dictionary.com, characterized by a very complicated, involved arrangement of parts, units. They should just put a router in the dictionary and call it a day. So if you look at network engineers, it's a lot of human device interaction. And they're doing a lot of things. They're touching a lot of different platforms out there. I once worked for an acquisition-heavy company, and we had 3 firewall vendors. And one does not simply flip a switch and migrate, to one firewall vendor. It's much more complicated than that. So, with that being said, network teams have a ton of different solutions. They have a lot of tool sprawl. Whether they're generating configs or they're using some box solution to manage certain parts of the network. So they have a lot of different solutions. And then all the different interaction surfaces that you're dealing with across all these platforms. If you go and you talk to the cloud team, everything's API. You go and you talk to another team and it's like, okay, we're using, pexpect or something like that, Ansible, this or that, or, these devices only listen on these things. So to kind of summarize this slide, you have network teams that are fighting fires all the time, and there's a lot of expectations. They're dealing with so many different devices and platforms, and they have a ton of solutions that they're using to do it, and there's so many interaction surfaces. And I think this is why it's a complex problem to solve at the end of the day. And another thing, so when you're dealing with physical hardware, obviously, this is mutable. You're looking at runtime automation. So I guess just give an example, there was a project I was working on. So I had a 5K refresh in a data center. So I unboxed the 5Ks. There was a procurement process. We racked and stacked those suckers. And then I'm going around and I'm putting a base configuration on these things. And then, next day I have Ansible Tower, and then I'm putting the rest of the configuration on it. And then all the subsequent configurations over time that get added to this, it's runtime configuration. I have these devices, they're running in production on my production network, and I'm incrementally making changes to them over time. And this is where, so I eventually got tired of fighting fires on the network side and just seeing this lack of progress, specifically in automation, and not being able to have the time to properly design. And I jumped ship and went to cloud. I was like, I want to get on the cloud side. The waters are much nicer over there. Whether that's true remains to be seen. And another thing too, so the mindset. So traditional network operators, you talk to anybody, and we're thinking about platforms, device types, OS versions, and there's so many of these things everywhere. And it's kind of like the pets versus cattle thing all over again. But then you jump into cloud, and things are different. These older connection methods are largely replaced by APIs. You have these API protocols, and these really enable. They give you a blueprint, and they give you consistency. So the responses you're getting, the payloads that you're constructing, you're maybe using REST. Not to say it's a perfect world. There's good and bad APIs at the end of the day, but it's more structured and it's more standardized and thus easier to parse and do things with. And then there's more, abstractions. So I kind of went from doing everything in general purpose programming languages to Ansible at some point, and now in the cloud world, Python is Terraform is huge. So, Terraform, and even some companies that have been around for a long time, Juniper. I was watching Cloud Field Day or Tech Field Day a few months ago, and they released a Terraform provider for Apstra. So this isn't something that's just a small thing. It's a big shift in the industry. This move towards more robust APIs. And then this was one thing where my mind started shifting over time, over a few years. Is okay, we're building this automation, and we're thinking in terms of instead of OS device types and things, we're looking at the whole network that underpins an application environment. So that slowly starts to change, and I slowly started getting to that cattle sort of mentality. So one API to rule them all. I don't know if you remember in Lord of the Rings when Boromir at the Council of Elrond came out, and he looked at everybody and said, one does not simply build one API to rule them all. And, well, actually what he really said was one does not simply walk into Mordor. But you know what? If you watch these movies, you know what the hobbits did? They walked right into Mordor. Right through the front gate. Or it wasn't through the front gate. I think it was through the back somewhere. I can't remember. But, yeah, they walked right in. So, honestly, to be clear, I would rather walk into Mordor than try to build one API to rule them all, because I honestly don't think it's ever going to happen. And should we even think about that? Should it be a conversation? Probably not. What can happen, though? So what can we do? So the more and more that APIs get adopted by lots of vendors, you have very distinct infrastructure domains. Say just connect. Let's just keep it simple: connecting networks, connecting VPCs, VNets, SD-WAN, IP, all these different things. You have a lot of different vendors out there. A lot of them have really upskilled, and they're getting in the API lanes. And you have a lot of vendor-to-vendor integrations. And I've actually seen a lot of big enterprises that actually build out all this automation on their own. They, have a lot of engineering talent. They, really moved the mark for their organization on keeping on top of these things. But a lot of times, network engineering teams are understaffed, and there's only so much you can do. And that's where looking at, okay, we're never going to get to some point where we build one API to rule them all, but maybe we can have like integration layers for subsets of infrastructure domains. And this is kind of like where I work now, Alkira. This is kind of what, the approach that we take, where, we have integrations with all, the cloud providers, or maybe Cisco, Infoblox, whatever it is, and then we have our API, our Terraform provider, and, we give that customer a single interaction surface to where, they're still doing all the work, but they have less touch points, less interaction surfaces, and a little less friction operationally. And this is, something that I've, personally seen. Like, I know Itential's here, we're partnered with them, but like when you get to that point where you have these APIs, and I remember, long time ago, there was one feature request. We were working with a vendor, and the old way of doing things like hardware boxes, OS types, and when programmability was not a big thing, doing vendor-to-vendor interactions at that point was really hard. They took a really long time, even if they got done in the first place. With API stuff, with the standardized data structures and everything, doing these integrations is a lot more seamless. It's quicker, and it just provides, more value in simplifying things. And this is only one way to do it. There's many ways to approach it. This is just, and this is what we're seeing now in the network and what we're doing. But other disciplines have done this a long time ago. Like, look at like the Slack ecosystem, or like all these other ecosystems where they've been building stuff on top of APIs for a long time, and they've built these robust ecosystems. They have all these integrations, and it's worked out really well for all these other disciplines. Why is network so different? And maybe it is a little bit different, but we still need to try to move that bar. And that's all I got. 10 minutes. If you want to talk, continue the conversation, or reach out. These are my tags. Thank you.
Thanks, William. Next up, we're going to take a slightly different look at Network as a Service from Jeff.
Thanks, Chris. Thank you. Hey, folks. I'm Jeff Loughridge with Konekti Systems. We help clients build secure cloud infrastructure. Today, I'll be talking about how enterprise WAN automation is being transformed through the offerings of the cloud service providers, or CSPs. We'll be talking about traditional WAN services offered by the telcos. We'll talk a little bit about how the CSPs began offering these network as a service type offerings, and how that's transforming the WAN with a focus on automation, of course. And then I'll close out with some final thoughts. All right, quick history of enterprise WAN. Back in the last decade of the last century, many of the offerings were telco offerings using what we now would consider legacy technologies like private lines, frame relay. In the mid-90s, we started to see L3 VPN being offered initially with IPsec-based overlays, and then as MPLS spread throughout the providers, we saw both L3 and L2 VPN being offered. More recently, in the last, 10 years or so, we've seen SD-WAN emerge with companies offering services to use commodity internet instead of more expensive MPLS VPN circuits. All right, traditional enterprise WAN automation, mostly non-existent or primitive. I think we've all been there. The expect scripts, the Perl scripts, Bash, just definitely not what we needed to automate the WAN. Imagine going back to 1998 and telling your engineer sitting next to you, hey, let's check in our entire WAN into version control. You'd get a crazy look. Back then there was no GitHub. We had CVS, and the server was probably in the guy's cube next to you. Not the good old days, definitely. In the last, 5 years or so, we've seen the CSPs, the Azures, the Amazons, the Googles begin to offer WAN services to enterprises. We've noticed that it's been very much iterative and incremental. We believe like the first iteration was for these CSPs to let you host your SD-WAN appliances in their infrastructure. So this was very much a do-it-yourself approach. You were the one who deployed those appliances and managed them. The second iteration was that the CSPs would let you use these native cloud constructs, like Transit Gateway. I'll use an AWS example, but it applies equally to Azure and to Google. You would piece those together. You build out your WAN with those components. It was really in that third iteration where they really empowered the enterprise to automate the WAN. You were able to purchase things like Cloud WAN from AWS, where not only could you get VPC to VPC in the same region, it was multi-region. It was data center to data center with AWS SiteLink. You were able to connect over a single pipe to resources, whether cloud or data center, throughout the world. Initially, a lot of the providers just gave you access to resources in a single region. When that changed in that third iteration, it really empowered enterprises to go out and buy and automate a WAN in a whole new way. Fully managed WAN, a WAN that you could check into Git. All right, I want to dive a little bit more into the network as a service aspect. I mentioned how you could use these cloud constructs to build out a fully managed WAN. This really streamlined your ability to connect data centers to branches, branches to cloud, data center to cloud, really all of those things in a way that you really could not do before. This was really, in my opinion, a very much a new thing. The CSPs offered this abstraction layer such that you didn't have to go out there and configure 5,000 devices, configure OSPF, configure all these things. Now obviously things like BGP aren't going away. You can't really abstract that away. But much of the complexity in the configuration piece at least is abstracted away when you purchase services from these CSPs. All right, we're at an automation conference. These CSPs offerings are very automation friendly. All the communication is API based. You're not ordering a circuit and waiting 6 weeks. You are going out and setting up new WAN connectivity on the fly. It's all API, all Terraform provider. It's no longer a manual interaction between the enterprise and the provider. A lot of times the connectivity is not described by things like routing, VRFs, or access lists that we're used to. It's described by a policy document that defines, hey, there's this cloud workload, HR, that must communicate with segment engineering, but you can't communicate with the R&D segment. All policy, you're not restricting or enabling connectivity based on things like routing. It's a whole different model. I wanted to give an example of that policy I was speaking of. This is an example from Cloud WAN, the AWS offering, that there's a JSON document that describes connectivity. It's probably pretty hard to read, but it defines a segment. I can only fit one segment into this. I think it defines, I don't recall the name of it, development segment, and describes what development can talk to and what attachments are part of that. It's not exactly familiar to traditional network engineers, more familiar to developers, but I think network engineers can get the hang of it. All right, let me dive into a little bit about the good, the bad, and the ugly. Obviously, this is a huge benefit for enterprise WAN and the ability to automate it. No questions there. On the slightly less positive side, I do feel like some of those traditional enterprise WAN engineer jobs might start to shift somewhat to the big CSPs. I don't know if you need 50 JCINEs or CCNIEs to configure your WAN at least if you're buying these services from the providers. On the very negative side, their offerings are very poor in the areas of observability, troubleshooting. If things break at 3 o'clock, you have just access to the very most basic of metrics. Good luck if you have reactive automation that's trying to automate service assurance. You're not going to get much currently. Nag your vendors. Now, what does all this mean to enterprises? Well, this is a great service, but it does come at a price. You are paying a premium for this new enterprise WAN fabric. It's going to be expensive. Very flexible, very agile, so I still think you're getting your money's worth. There's no real need to automate individual devices anymore. You are using Terraform or policy to go out and make this new enterprise WAN fabric happen. I mentioned how these solutions are a little bit more developer-centric. You see things like Cloud WAN or Virtual WAN from Azure, Google Network Connectivity Center. A lot of the things that you're seeing are probably more familiar to developers. Other folks can definitely learn. You're not seeing a more traditional VRF type thing. There are some pretty important benefits of this new enterprise WAN fabric. One is in the area of ephemeral WAN connectivity. Imagine that you're at an event like this, where you need temporary connectivity, both data center and cloud to cloud, data center to branch. You could do that with this new technologies. If you wanted to do backups at 3 o'clock in the morning and have temporary connectivity just for those backups, you can make that happen. In addition, I'm very impressed with the way you could do disaster recovery. With pure cloud, you could do a full region DR type setup back in 2012 or so. But imagine now, not only can you do that, but you can swing your new enterprise WAN fabric, build out new connectivity data centers in an instant. All right, some final thoughts. I think this is definitely going to drive the need for some automation skills, the ability to write Python, communicate with an API, to write Terraform templates. Those are things that engineers will need to learn. I feel like networking has always been a laggard in the networking space. I'm sure most folks here also see that as well. I feel like these new technologies give the DevOps organization and the enterprises the ability to absorb networking, at least the WAN piece, in a way that really could not be done previously. At least on the WAN side, I feel like you're bringing networking kind of up to where the DevOps folks are. And then lastly, I mentioned visibility, very much lacking. Please talk to your vendors, AWS, Microsoft, Google, and tell them what we really need in those areas. We need the ability to get very granular metrics, to know what's happening. It should not be this black box. In closing, I would say if you're an enterprise architect or you advise an enterprise architect, think about how these new CSP WAN offerings and the associated automation can transform your WAN in some very impressive ways. Thank you.
All right, our last lightning talk before we open up the questions is from Mark, talking about some lessons from public cloud. Mark has only about 420 slides, but he promised he can get through it in 10 minutes. So I want all of you to time him. Thank you.
Okay, 10 minutes. Let's do this. So my name is Mark Ciecior. I work for Carrier Access IT, a traditional VAR based in Des Moines. And I'm going to talk about lessons from modern-day developers who quite often use public cloud. So there have been a ton of excellent answers to this question over the last day and a half. But one of the things that strikes me, given that I live and work in Iowa, which many, perhaps most of you, flew over to get here today, is that there's so much mind share out on the web today around what the big guys are doing. And while I find that very interesting in and of itself, it's not all that relevant to a lot of my customers in the small and medium-sized areas. So Chris and Scott sent out a survey of attendees beforehand. I was kind of poking through the results, and a few things stood out to me. Roughly 21% of the respondents said that they were in the early stages of network automation, and 26% said their change processes are entirely manual. And then I wanted to find out how prevalent are the big and small companies. So last night I poked around on the Bureau of Labor and Statistics website and found that 60% of US employees work at firms with fewer than 1,000 employees. So that says to me there are a lot of what I would call small and mid-sized customers, and a lot of attendees, even in an automation conference like this, feel they are on the left side of this adoption curve, who may not be sure where to invest their time or what are the best ways to approach things. And while there are no perfect answers, my goal here is to simply show you an approach that's worked for me as I talk to some of my small and medium-sized customers. And the tooling that we're talking about today are the three topics you've heard roughly 375 times in the last day and a half, but let's dig into them a little more. So the first set of problems is related to configurations. And there are several questions that pop up you're dealing with configuration data. One of my favorites is when you're looking through a config and you think, who did that? And its corollary, hope it wasn't me. And there's that final bullet point, the declarative versus imperative. I think one of the first speakers yesterday talked about the switch port trunk VLAN without using the add command in there. And when you think about today, how you move from configuration as it exists today to what you want it to be tomorrow, there are some mental hops you take in deciding in what order you apply these commands to make sure there's no outage, et cetera, et cetera, et cetera. Those are all imperative steps that you're defining how something needs to be done. And it can be easier if you can simply offload that work to a vendor-provided Ansible module and let them do the harder work of deciding how the configuration should be implemented. So one of the ways we can solve this is, ta-da, infrastructure as code. So what does that mean if you are on the left side of the adoption curve? What does that mean to you? So a very rough example here is a YAML file on the left where I'm not trying to digest the entire configuration of a particular device. I'm simply looking at one switch with 3 ports that are members of 1 or 2 VLANs. And if I want to start small, this is a perfect use case where I define a little bit of data here. I check in this file to a Git repository, and then I can make use of a vendor-provided Ansible module, be it Cisco, Arista, Juniper, what have you, and I can run this playbook to affect that change on my network. And most of these vendor-provided modules are idempotent. I can run it once, it makes a change. I can run it again, there's no impact. I can run it again and again and again, every hour, every day, however often you need to, until change becomes something that's not so scary and something to be avoided. And when you check your configuration into a Git repository, there are a wealth of features you get for free, like attribution. There's a feature called Git blame, where you can see who made the last change to any particular line in a configuration file. There's a whole series of approvals that you can apply to your specific organization. And then, of course, there's a Git log option to audit who made what changes to your configuration over time and why. So our second set of problems we deal with is related to validation. And testing and network assurance has come up quite a bit the last few days here. And I guess what I'd like to point out here is that you can compare the configuration from yesterday to today, and they could be entirely the same, but that says nothing about the state of your network. You can imagine your spanning tree route or the contents of your routing table or the HA status of your firewalls having changed from last night to this morning, even though the configuration looks and feels the same. So one way to help get over those hurdles is what we call functional testing. So developers have for a long time been able to write tests for each and every one of their functions. They give a certain set of inputs, they expect a certain set of outputs, and they expect it to succeed or fail under these conditions. The idea being that as you test your smaller pieces, there are fewer problems as you put your whole code base together. So there's a Python project out there called PyATS, originally developed by Cisco, but includes modules for a whole host of vendors, which lends itself well to this functional testing idea. So on the left, I've got a series of available parsers for Juno specifically, looking at show route here, and you can see that running this show route output through the parser provided by PyATS gives you this structured data JSON file on the right. Now what can we do once we have our network state in structured data? Well, we can write a Python function to run that show route command, parse through the routes, and then we can start asking interesting questions. Does this route on router A also exist on router B? Are they the same? Are the number of routes in both lists the same? If I compare that to the data I got yesterday, are they the same? Has something changed? And again, even if the OSPF configuration hasn't changed, perhaps I've learned or lost some routes from yesterday and I want to be made aware of that. So I searched on GitHub for a good example of a PyATS test script. I blatantly stole this one from Danny Wade's repo. And then last night, I ran into him. He's here, which is further proof that Scott and Chris invited all the cool people. And then as I was talking to him, he told me he's writing a book on PyATS that's coming out next summer. I digress. Anyway, PyATS includes a nice HTML formatted outputs, so you can dig into the details of all your tests and why they passed or failed, when and where. And this output could be saved to some storage location or emailed to you every morning, or it could be run after every change you make. The idea being that if you make some change at 10 o'clock at night, you can validate not only that your change was effective, but you didn't break any of the other things that your network is intended to do. You can tell your boss it worked, and when I left at 10 o'clock last night. And if you extrapolate that idea forward, you could consider running this every night or every morning at 6 a.m. So when you get in to the office in the morning, you fire up your inbox, and you see at the top of your inbox are the results of a state check of your network. So if there are issues, you can be proactive about fixing them, and if there aren't, you can feel more confident that you're not going to be fighting fires today. You can actually do something useful. And the last set of problems we're going to talk about are related to automating all the things all the time and keeping a log of what happened. So there are questions around testing here, and I think an issue relates to standardization and making sure that not only you do the same thing every time, but everyone on your team also takes those same actions every time. And so a way that developers have dealt with this for a long time is what we call pipelines. So today, and for many years, developers have been able to check in their code changes to a Git repository, and that kicks off a pipeline run, which is a series of actions. Could be to test their code, to test just their functions, to test how it works with someone else's functions, to test the whole boatload of code altogether. At the end of the day, this pipeline device is just a Linux box that can do whatever you ask it to do. It could run an Ansible playbook like we saw initially. It could run some sort of validation function. Most of the major CI platforms allow you to write your pipelines in certain stages so that the build stage needs to pass before you start testing it, and if the testing passes, then you can run your playbook to actually affect change, and once that's complete, you can run your testing again to verify that your change worked and nothing else went sideways. And then, of course, these pipelines keep a log of what has been done, so you can see who changed what, when, whether each of your individual steps succeeded or failed. And then on the far right there, next to that red X, there's a little download arrow. There's a concept of saving artifacts, so that HTML output of your PyATS run could be saved as an artifact of this particular pipeline run. You can come back in 2 weeks, 30 days, and find out, did this route exist way back when did something change? You've got a record of the state of your network, not just the configuration. I've got 19 seconds left. Ready for questions.
Nice. All right, awesome. So I think we have enough time for 3 questions. I'm going to ask the first one, but there's 3 more after that if you want to run to a mic. The first question, I think those were all great presentations. Thank you guys, Jeff, William, and Mark. That was fantastic. I think we got some good insights there. If we had to boil it down, if you have one lesson from the public cloud that you could bring to networking that everybody could take home with them, maybe like 10 seconds, right? The one sentence, like one lesson you've got from public cloud to bring to networking. Mark, we'll start with you since I butchered your name the worst. Which may have been punishment, not reward, I realize now.
My chief piece of advice would be simply, don't try and boil the ocean, get something done.
I like it. William? I think it's already on.
Oh, right on. The cloud providers have very diligent free tiers. And when I was getting integrated with all this stuff, I just built. Go build. It's free. If you have the time, experiment. Get to where you understand it a little better. And I think that's a great first step.
What do you have to add, Mark?
I would say evaluate. I'm a big fan of
Jeff, sorry.
No problem,
Jeff.
Jeff. I'm a big fan of proof of concept tests. We've done a lot of work with a major financial service provider in the United States, doing a lot of those tests. Get out there and test Google's Network Connectivity Center. Test virtual WAN. Test cloud WAN. If you don't get some hands-on experience, you might not fully be able to grasp the benefits. Try it out.
I think that's all great advice. To summarize and harken back to Garrett's presentation, I think it's do or do not. There is no try. Just go do something. Yeah? All right.
Question for Jeff. What can you say about the challenges of still having that cloud access circuit, that cloud access connectivity, I still have to get to the cloud to use cloud WAN type services. What are some of the challenges you see with that boundary?
Yeah, I think even today you still have this coupling to the physical infrastructure, like circuits that you can't fully escape. Fortunately, there are companies that are kind of helping with that. You've got companies like Alkira or Megaboards or Packet Fabric that are making some of that a little bit more easier than it was. To me, I think that is very much the biggest challenge that I've seen.
William can comment on that too if he has anything to add.
I think in looking at some big companies that have tried to take this journey already, one big benefit out of the gate that they're looking for is reducing. It's not about we've got to get rid of all physical hardware. It's how can we reduce it, because we only have so many engineers. We have to do life cycle refreshes for all these things. And speaking from experience, I got the opportunity to work for 15 years in the enterprise space, and it was like hardware overload. We had way too much hardware for the problems we were trying to solve. Back to honestly network design, but it's really hard to rip out once you have these things in place.
Awesome. Okay, here we go.
So to the panel, do you feel that the cloud service providers have feature parity with your traditional WAN circuit providers? And if yes or no, what direction do they need to go in? Thank you.
Let's jump in first.
I would say no, not quite feature parity, but the benefits in terms of flexibility and agility, to me at least, vastly outweighs some of the minor lack of parity.
Any other thoughts? No? All right. Well, thank you, Mark, William, and Jeff. Appreciate it. That'll be that session.